Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Ibnu. Today, I'm going to talk about our study entitled Numerical Simulation of MCC Evaluation over Borneo Island using high resolution model for case study 14 to 15 April 2012. MCS or mesoscale convective system is an organized cluster of convective clouds. This is larger than an individual cloud. These MCCS types consists of MCS consists of three types, which are MCC mesoscale convective complex, squally, and boechoes. In this study, we will investigate the MCC case. Yes, MCC is a particular type of MCS which is large, circular, long-lived cluster of showers and thunderstorms identified by satellite. These are the physical characteristics of MCC defined by Maddox in 1980. They have a particular size, initiation, and duration, the maximum extent, shape, and termination. These are the graphical distribution of MCC in 15 years from 2001 to 2015, presented by Tismedianto et al. This important information shows that in Indonesia, the about 80 to 20% of MCC mostly frequently occur in the West Sumatra, South China Sea, Central Kalimantan, here, Sulawesi, Merauke, Indian Ocean, and Indian Ocean. Borneo or Kalimantan Island is home to 5 major cities as well as Indonesian feature capital city, Nusantara. The study of MCC that may cause extreme rainfall is critical. An assessment of the regional model's abilities in simulating the evolution of the MCC over Borneo is important to improve the accuracy of model prediction of the MCC. Only few studies have discussed the evaluation of model performance to simulate the MCC over Borneo. The goal of this study is to assess the performance of the regional models in simulating the evaluation of MCC over Borneo Island. To evaluate the models, study case of MCC on 14 to 15 April 2012, as discussed in Trismedianto, was chosen as a reference. This study focused on one incident of MCC that occurred on the island of Borneo on 14 to 15 April 2012. Based on Maddox criteria, Trismedianto et al. Recognized this case as one of the convective systems that meet the MCC characteristic. The long lived MCC is MCC is characterized using cloud top temperature information derived from the MTSat satellite infrared 1 channels. In this study, the simulations will be carried out using WRF models. These are the WF configuration, which consists of two domains, 9 kilometers and 3 kilometers, with 60 vertical levels, and with cumulus schemes in first domain. We use Best Miller Genjic, and for microphysics, WSM 6. For PBL scheme, we use Yonsei University, and so on. And for initial and boundary condition, we use the ERA 5 models, and the time investigations is 2 days from 13 April 18 UTC to 15 April 18 UTC. The first 24 hours is considered as spin-up time. This figure shows the MTSAT's observation for the top panels from 14 April 13 local time to 17 local time. And the bottom panels show the output of WF at this similar time. So a combination of mountain valley breeze in the northern and middle part of the continent contribute to the initiation of convective activity of a middle and the coastal of Borneo. The model simulates the ancient stage with less convective cells found in the continent's middle and the southern region. As you can see, we have a less convective cells in southern and in the mid of continent shown by the models. And from 14 April, the first local time to 15 April, 1 local time, the MCC reached a mature stage around midnight when a broad convective area spread around the southern, the middle, southern, and eastern part of the continent. Then it propagated to the middle of the continent with cold temperature of less than 200 Kelvin. Can be found in the southern part. The WRF model assembly simulates the mature stage of MCC. However, no convective cells simulated by the model in the south of continent. Next is the merging and weakening of convective cells shown in the eastern and middle part of the continent as the MCC entered the decaying stage. And the land breeze promote a squall line. The land breeze in the south of continent promote the squall lines that propagate southward. The model successfully simulates the decaying stage of FCC with surface wind divergence comparably. So the model comparably simulates these features. However, the model, however, the squall line in the south of Kalimantan is not present yet. A few hours later, as the sea breeze returns, neo-convective cells form along the north and the south coast, and the squall line that propagates southward, it arrives on Java Island in the afternoon and lasts for 5 to 16 hours before decaying. The model simulates post-emphasis, comparably simulates the post-emphasis stage and the squall line in the south. However, model simulates the presence of squall lines 4 to 5 hours later than the actual squall line. The next experiment, we run two kind of experiment: the contour experiments with actual topography and the flat experiment with flat topography. So the red contour is associated with the contour experiment with actual topography, and the blue contour is associated with the flat experiment with flat topography. Topography as indicated by this shaded field contour located in the north of Borneo continent could enhance the convective activity during the initiation and growth stage more than in flight simulation. As you can see in this orange box, we have less convective cell as indicated by blue color line. These blue color lines indicates the black body temperature of 210 value. And more convective cells grow to the south of mountainous region in control experiment than in flat. As you can see in this green box, from 22nd local time to 2 local time on 15 April, we see that we have less convective cell in the flat experiment. So after the convective cell grows in the south of the mountainous region, it moves southward and merge with the other convective cells. And we also found that on the east coast of the continent, the flat simulation you see in the red box, the flat simulation generates convective cells earlier than the control simulation. So this is a summary of the study. The WF model could simulate the evolution of MCC occurred on 14 to 15 April from the initiation to this dissipation and post MCC stage. The evolution past and minimum cold temperature are also successfully simulated. The model also simulates the post MCC stage, such as in this squall line that moves toward Java Island. However, there are differences in spatial distribution, and the cell size simulated by the WF model is smaller than the observed MCC, in particular in the south of the continent. This study confirms the role of mountainous region in Borneo continent, which gives rise to more convective cells, thereby increasing the strength of a coverage of MCC over Borneo. This study also allows researchers to delve deeper into the underlying mechanism of MCC life, which can last for several hours across Borneo. Thank you.